Welcome to today's event. We are here to learn about the new AWS Certified Solutions Architect Associate Exam, SAA C03, which is live from September 1, 2022 forward. You need to know what's new, what it means, and how to be prepared for those topics on the new exam. So, without any further delay, let's get started.
Hey everybody, welcome to the event. We're here to talk about AWS. And as you may know, if you've been preparing for the AWS certifications, they update them periodically. And we're very close to an update to the SAA exam to version C03. In fact, going from September the 1st forward, that will be the only version of the exam. Now, to be clear, AWS or Amazon is a little different than a lot of other certification providers. So many certification providers will give you a bit of an overlap period, maybe 30 days, some as many as 90 days, where the old exam continues to be available and the new exam is also available for those that are just beginning their studies. Part of the reason that some organizations do that overlap is so that they can be sure that students that are studying for a current version of the exam, and maybe they're doing it through a college program, for example, are able to finish that version of the exam. So that is one of the primary reasons why they allow the overlap. AWS, on the other hand, evolves their exams based on the evolution of the AWS platform, and they've just made the decision that when a new exam is out, the old exam is no longer available. They generally give a notice of several months so that you do know that it's coming, and they're pretty good about meeting those deadlines as well, so you know the new exam will be available when they say it will be. So we're looking at the move from SAA C02 to SAA C03. And of course, this is the AWS Solutions Architect Associate certification. Now, here's the thing to keep in mind. You still need to know the other stuff. So that is what was in CO2. Pretty much all of it is still covered. And you will need to know some additional things as well. So the purpose of this live event is to help you begin to wrap your mind around some of those new things that you might need to know about that are not covered in our current learning materials. So we want to make sure that you have what you need to be prepared for that. All right, so at this point, what we want to do is begin getting into some of the different areas of new things. Now, certainly in an hour like this, I don't have time to go into all of the details of every one of these components, but I will give you an overview of them and help you to understand what they mean to you as far as the exam. And then at the very end, I'll give you some guidance on how to go about getting more information and so forth. And of course, the actual full course that is available will be updated to include full coverage of all of these as well. So the first thing we want to do is look at security topics. So we're going to talk about the different security-related topics that are new on the exam or maybe enhanced on the new version of the exam. So the first thing we'll talk about is this thing called the AWS STS. AWS STS is the Secure Token Service. Now, you already saw in the objectives when we looked at it that it was mentioned there, right? So you saw that it's clearly part of this because it was right there in those objectives that we saw. So what is it all about? Well, the Secure Token Service provides temporary and constrained credentials. Now, what do I mean by that? Temporary in that the credentials are available on demand. So the authorization token, if you will, hence Secure Token Service, is provided on demand and it is constrained. So there are rules related to that token as to the maximum capabilities that the account will have, this temporary credential will have, okay? So they're temporary and they are constrained by rules or policies. And then also they can be used in a number of different ways. So you can have internal IAM users that can request a temporary credential. Rather than it being part of their default permission set, they instead are granted the capability to request a temporary credential. And then they use that to do a thing. So that gives a little better security if you think about it. And I don't have time to get into the theory behind why it's a little better security in great detail, but let's just say it like this. If someone gains access to my IAM user account and they don't know that I have the capability to request a temporary token or temporary credentials, then they don't know to try it, right? But if my account simply has direct access, that's a whole different ballgame. Once they have my account, they have access and they can just go in and start using things. So there's that little extra layer of security that can be provided there. And then it also can be used for federated users. So users coming in from maybe organizational or enterprise Active Directory accounts, or maybe they're coming in from other AWS accounts. But federated means users outside of my organization, right? And I can bring them in and give them temporary credentials. And one of the key uses of it, and one to really watch out for on the exam, is the AWS service roles. So what we're talking about here is a service, maybe an EC2 instance, needs to be able to access a S3 bucket or some other resource. Well, normally the EC2 instance, which is just a virtual machine, right? It can't really get into the S3 bucket, but there are a couple ways we can do it. We can assign a user identity to the EC2 instance, and then it can do it. But now you got this user identity that has this capability, and it could be breached and they could gain access. So instead, what you could do is you can use the secure token service. You can request temporary credentials based on roles, and then that EC2 instance simply takes on the role and can access the S3 bucket. So there are several different options here for how you might use this service. But know that it's really a service that's just kind of there in AWS. It's a utility service. It does the work. So you don't really go and configure STS per se. Instead, if you set up an EC2 instance to use a role with a temporary credential, then STS is going to be used to make that happen. It's part of the AWS architectural structure. Now, the next thing we'll talk about is the AWS Control Tower. We do talk about it briefly in the course, just from a definitional perspective, but I want you to know a little bit more about the AWS Control Tower. It is for managing multiple accounts. Now, we talk about AWS organizations in the course, and this, you might say, sits above the organization. So it's like a control tower above your organization, right? It creates a landing zone with these AWS organizations. So the AWS organizations exist and they're incorporated into the control tower. The benefit of this is we can set up these high-level policies, rules, controls for what can be done within our entire structure, not just a single organization, but all organizations, right? So we can set up these policies that then can make it so that anytime an account is created anywhere, it's constrained by those policies coming from the control tower. So I'm not going to accidentally have one AWS account with one set of policy rules for IAM users and another one with another set of policy rules. I'm going to have these universal policies that are pushed down throughout not only my organization, but possibly multiple organizations. The governance can be extended then to additional accounts at any time. So at any time, I can add a brand new account and say, okay, control tower, go grab that account. Or maybe the account already exists, but I didn't initially put it under the umbrella of the control tower. I can have it take control of that account as well. So of course, obviously I need to have credentials and authorization to make that happen, but I can do that. So that is the AWS Control Tower. Creates a landing zone, accounts can be created and constrained by central policies, and governance can be extended at any time. These are the key things to remember about the AWS Control Tower. Now the next thing is service control policies. Service control policies are used to manage permissions within an organization. So whether you're using the control tower or not, you can still use control policies. And what they effectively do is create what you might think of as maximum available permissions. So what it says is, all right, you can give people access to these things, but in our organization, they can never be given more than a certain level of access. So maximum available permissions are defined. It puts what you might think of as default constraints within the environment. The organization must have all features enabled to use this. Now, what do I mean by that? Well, it's not actually uncommon for people to use organizations just for consolidated billing. For example, if you have 3 different AWS accounts and you set them up separately and they're not in an organization, then you're getting 3 separate bills for those accounts each month, right? They're being paid separately. You might want to consolidate those together. If they're all in an organization, well, then they can all be done. You can say, do the billing through the organization and simply consolidate all of my billing. So that's a great benefit of utilizing an organization. And some organizations, that's all they use it for. But if that's what you're doing and you're not using all features, then you won't be able to take advantage of service control policies. To use them, all features have to be enabled. So make sure you keep that in mind for the exam as well as if you attempt to implement this. Now, there's some more services that we should know about in this area of security as well. And the first one is Amazon Cognito. Amazon Cognito provides user sign up, sign in, and access control for web and mobile apps. So if you have web apps, you have mobile apps on mobile devices, and you want those device apps to be authenticated in some way, Amazon Cognito provides that to you through the cloud. So you don't have to worry about building your own authentication architecture, authentication structure. It's all provided through Amazon Cognito. Amazon Guard Duty is, I call it sort of an intrusion detection system. It could be classified as an intrusion detection system, but what it does is it provides threat detection related to accounts and workloads. So it's limited in what it does. In other words, it's not necessarily a full-scale packet analysis type intrusion detection system like many of them are on our enterprise networks, but it is something like that. Now, by the way, let me be clear. Because you have full control over where traffic flows in your AWS deployment, you have configuration of VPCs, whether or not traffic can route from one VPC to another, through what it must be routed and so forth. You could deploy any IDS, IPS solution you want within the cloud that's based on, say, a Linux operating system. So you could have EC2 instances in each of your VPCs that all they're doing is intrusion monitoring. Always keep in mind, I've said this in the course, I say it anytime I teach on the cloud. The cloud is basically taking all the stuff you do on your local network and putting it on the internet on someone else's network. But it lets you virtually configure it all within your own little constrained world to what you want it to look like, do, and be. And so you still have the ability to do some of the same things you might do on a local network within AWS. Now, the difference is that on your local network, you might have a network appliance that sits between 2 network segments. And that's the thing that's doing your intrusion detection, right? As traffic flows from one segment to the other and vice versa. Instead of that, you would have to implement your own device within each of those VPCs, segments, and then configure the intrusion monitoring on those devices to watch the flow of traffic through the segments. So it's a little different how you do it, but you can accomplish some of the same end results. Now, we also have Amazon Macie. This is a very interesting solution and very important for many organizations today. If you're involved in the healthcare industry, for example, or the insurance industry, things like that, and many others as well, then the issue of privacy is very important to you. In some countries, it's legally important. In all countries, it's very important. And the concept is that what we want to do is know if there's any PII information coming into our system, going out of our system, and so forth, and then properly deal with that information in whatever way. Maybe you're going to do obfuscation, maybe you're going to do encryption, whatever it happens to be. The point is dealing with that PII information appropriately. Well, that's what Amazon Macy's all about. It scours all of your different locations, S3 buckets and things like that for PII or other information you define as sensitive information. So it looks through your data to find this for you, and then it will alert you when discovered so that you can address it appropriately. So Cognito, sign up, sign in, and access control for web and mobile apps. Guard duty, threat detection based on monitoring of accounts and workloads. And Macy is monitoring for the ingress or egress of PII and other defined sensitive information. Now let's talk a little bit about some threat vectors within an AWS solution. And there are a couple specifically named in the objectives that I want to address. The first one is a distributed denial of service attack, DDoS. First of all, a DOS, a denial of service attack, is simply an attack where the attacker attempts to prevent authorized users from being able to use the resource, usually in one of two primary ways: by consuming all of that resource, such as CPU, network bandwidth, etc., or by causing the service to crash so that it's not available. So a couple of different ways that denial of service is often employed. Distributed denial of service is usually a resource consumption attack, which may result in a crash, but the first step is resource consumption. And the way it works is, instead of attacking from one device to your service, I'll attack from 1,000, 10,000, 1,000,000 devices to your service. And I'm going to use something nowadays that we call a botnet, right? So here's the thing to keep in mind. A lot of malware that goes around on the internet is not really about destroying your data, stealing your data, or anything like that. It's about using your resources. So some malware, all it wants to do is make you a bot on the attacker's network. And so if I can get 1 million people to click on something in an email address that installs a component on their system that allows me to use their resources to attack someone, then I can use those million computers to launch an attack against someone else. Now you might think, well, surely no one could do that. There have already been botnets that were larger than 1 million nodes in size. So yeah, it can be done. So what is the point then of this within AWS? Well, it helps you understand the reason for AWS Shield. So AWS Shield is specifically designed in AWS to provide a level of DDoS protection at layers 3, 4, and 7. Now, if you don't know networking in detail, maybe you come from more of a development environment or a programming environment, something like that, and less from a networking environment, what we're talking about when we say layers 3, 4, and 7 is the OSI model. 1, 2, 3, 4, 5, 6, 7, right? So you have the physical layer at the very bottom, layer 1, then you have the data link layer, then you have the network layer, the transport layer, and then you have the session and presentation layers. Those are 5 and 6. No one hardly ever talks about them. Notice that we say here protection at 3, 4, and 7. We just kind of skipped over 5 and 6. It's because, people don't really deal with the session and presentation layers very much because they're not as well defined as to what protocols really fit there. And then layer 7 is the application layer. So when you think application layer, think HTTP, right? Or maybe SMTP for email, something like that. So what this does then is it implements different technologies to make it so that if someone launches a denial of service attack against your particular service, then it can redirect valid incoming requests to another location. Redirection is about the only temporary fix for DDoS. We've got to make it so something else is available, maybe based on DNS, to gain access to an actual resource. Okay, so that is the concept of AWS Shield. The other threat vector they explicitly mention is SQL injection. Now, an SQL injection attack is an attack where the attacker forms either strings in fields within a web application that add SQL code to the string they're sending and therefore change the SQL code on the back end so that they can add commands to be executed by the database server, which could result in the gaining of access or the exposure of extra information. The simplest example would be that a field requests your customer ID. And instead of putting in the customer ID, I put in an asterisk. And then for some reason, that back-end application isn't coded right, and it just dumps all of the customer records out onto my screen. So that's the simplest example of what it might be like. But there are other injection attacks that are specific to certain databases and that are just going to execute other malicious commands that could gain access to data or even destroy data. So that's an SQL injection attack. The solution to that within AWS is what's called the AWS Web Application Firewall, or AWS WAF. And basically what this does is pattern recognition for SQL injection attacks. It does also help support against cross-site scripting attacks. Cross-site scripting attacks are where, I'll give you the simplest example of it. You've probably seen a website that has an ad on it, right? If not, you may not have been around much on the internet. So you've probably seen a website that has an ad on it. Now, very few of these websites are picking the ad in some direct static manner and putting it on their page. They're subscribing to an ad service. And all they do is inject JavaScript code usually, but some kind of code into your web page. So when users come to your web page, that code gets to be displayed. Well, cross-site scripting would be that there's malicious code in that code coming actually from another web server. Okay, so that's cross-site scripting, is the simplest form of it. There are some very complex forms as well. So AWS WAF helps to protect against these kinds of attacks. And those are your threat vectors. And then one more thing to wrap up the security section here is some data security policy considerations, some things to consider related to policy. The first one is access. You need policies that define the access rules for AWS. They need to define rules for users that actually have AWS accounts, but they also need to define rules for API access, so applications coming into AWS. These are important as well. Then you need governance policies. These are policies that stipulate how the AWS deployments must be monitored and managed to ensure they comply with our security and also privacy requirements. Then you have data classification, retention, and recovery. Data classification is about identifying the sensitivity of the data, generally speaking. So very sensitive data may be classified as high, moderately sensitive data as medium, and data that is not sensitive at all as low, right? High, medium, low, or top secret, secret, and public, what have you. So you can have whatever names you want for it, but you have data classification. And then that classification is used in the building of security roles and user account permissions and things like that based on the data. And then there's retention. So data retention is about how do I keep data, archival data, personally identifiable information, what's going to be kept, what's not, and so forth. And then you should have policies about recovery. What happens if I lose my data? How do I get it back? Some people might think, well, I put it in the cloud and all is good. Well, you can't think of it that way because let's say you're running a MySQL database instance in RDS. Do you think that database could get corrupted there just like it can on your own local database? What's the difference? Well, it's running in a virtual database server, kind of. We don't know all the details about what AWS does in the back end. We don't know. We don't know all the details. So we don't know exactly how it's implemented. We just know it's still running MySQL, right? So I've got it. Well, here's the thing then. You have to be backing it up because you have no way to trust that any more than you'd trust your own server, other than maybe they've spent more money to have better fault tolerance than what you could afford to do within your organization. But other than that, you have no way of actually knowing that they are not going to lose your data. That extreme scenario could happen. And so you need backups. And that's why there are backup services built in. So recovery procedures define how you're going to make sure that you're retaining retention procedures, define how you're going to make sure you're keeping that data, backing it up if you need to. And then recovery procedures is how do you go about that recovery? How do you go about getting it back if a database is lost or just some portion of the database is lost? Then you have your encryption key management and AWS secrets manager. Now this is important as well. So encryption key management is about managing any encryption keys that are used anywhere throughout AWS. I don't know if you've ever had a scenario where you lost an encryption key or not, but that's not a good thing, especially if you're using good encryption. You know, if you're using advanced encryption standard, AES 256-bit, and you've encrypted a bunch of data on a hard drive, and then you lose your encryption key and your recovery password, and you just have no way to get back into it. You are right. You have no way to get back into it. So encryption key management and other secrets, managing them through AWS Secret Manager can be very, very important to make sure that we have some mechanism by which we can recover. And most systems are going to give you some kind of a hierarchy of recovery. So that is to say, this level of person can recover these people's keys, and these people can recover these people's, and so forth. And maybe there's even a dual requirement. So two people together have to recover a key rather than just one people, so that I can't go in as someone with authority and recover a key that maybe I shouldn't be recovering, but I need the assistance of a cohort to go in and recover that key. Then you have federated directory services, which basically allows you to use other directory services. Maybe they're LDAP, which Active Directory is LDAP as well, but some other directory service in accordance with my AWS account. And that can give me a single sign-on. And I can also make it so that an AWS account can sign on to an AWS user can sign on to one account and then access resources in other accounts as well. So all of this is the concept of federated directory and AWS single sign-on. And then finally, we have some firewalls, and I've already mentioned these, but if you need security policies for firewalls, remember you've got AWS Shield, which is a sort of firewall, sort of intrusion protection detection system. It's more of a detection system than a firewall. It's more about notifications. And then AWS WAF is indeed a firewall. So these are our data security policy considerations that we want to make as we're wrapping up this section here. And that moves us to the next section where we talk about resiliency topics. We don't have as many topics here in resiliency or in the other sections as we go forward. So resiliency is about being able to operate in the event of a failure, an error, a catastrophe, something like that. So there are different things that come into play here. One of them is the AWS transfer family. The AWS transfer family can fall into the resiliency category because it allows you to transfer data from one location to another in a secure manner. This is often done to partner with service providers or with other companies or simply with other AWS accounts for that matter. But basically, you're going to use SFTP, FTPS, or FTP, hopefully not, because that's not secure, to transfer data. And you'll transfer that into S3 buckets or Elastic File System and so forth. And then you can do whatever you want with that data once it gets into AWS. It can also use the AS2 protocol for communications with a partner. That partner in that case would usually have their own AS2 server, and then data is going from their server into AWS using the AS2 protocol. So this is what they call the transfer family. The four protocols are SFTP, FTPS, FTP, and AS2. Now, we also have DevOps related concepts important to think about here in resiliency. And the first one is Elastic Kubernetes Service. Elastic Kubernetes Service is the ability to deploy Kubernetes within AWS in a manner that can grow and shrink as needed, right? Hence Elastic. Now, Kubernetes is a way to manage your container deployment and use. So Docker containers, for example, are common containers. And a container is a way to bundle up an application or a service, in many cases of enterprise deployments, so that when I need that service or I need that application, I launch that container and I get it. And if that application or service has dependencies, runtimes, things like that have to be on the system, it can all be part of that container, right? So I can run a container manually. I can sit down, go to a command line, launch a container, use some GUI tool to launch a container, kind of on demand whenever I want it. But what if I want something to manage dozens or hundreds or thousands of containers for me, deploying them as needed, removing them when they're not needed, and so forth? That's where Kubernetes comes into play, and Elastic Kubernetes is Amazon's implementation of it within AWS. We also have support for REST APIs, as well as pub-sub communications. Pub-sub communications mean that I have publishers and I have subscribers, pub-sub. And there's some type of a gateway, proxy, service, whatever, in between them, right? So the publishers push to that in between, and the subscribers pull from that in between, or the in between might push to the subscriber, depending on the configuration, if it's a push or a pull subscription. And so pub/sub is that basic model. There are all kinds of protocols out there that use pub/sub. MQTT is one example of it, the message queuing telemetry transport protocol. And that protocol is one that's supported in AWS, but it's often used, where pub/sub is often used is in IoT deployments. So kind of watch for that as maybe a giveaway within the exam. REST APIs are basically HTTP query and response. And so I send an HTTP GET or POST message to the service. The service responds back with an HTTP response, which may or may not contain a bunch of data. The data could be in JSON format, it could be in XML format, what have you. And so those are REST APIs. Now, I don't have the time to get into the details of all the constraints that say this is a REST API and this is not because it doesn't meet one of these 6 core requirements. I don't have the time to get into all that, but it is something you can look up on your own. Just know that REST APIs are supported. Microservices are another concept. Microservices, it's the concept of breaking a service apart into multiple components that might be beneficial to other things. So let's say, for example, I have a monolithic service. Monolithic is the term we use for the old thing where one service does everything needed by an application, right? So I have this one monolithic service that's really 25 different capabilities. Well, what if 3 of those capabilities could be used by 14 other applications? And I'm reinventing the wheel every time. I'm putting those things in every one of the monolithic services again and again and again, and reinventing the wheel. Well, with microservices, those services that could be reused and beneficial to the things can be broken apart into separate deployed services. And then those services can be consumed by multiple applications. Now, that's one benefit of microservices. Another benefit of microservices is the ability to deploy my application in more of a componentized format. Instead of one monolithic thing that has to run on one server, I can have maybe 3 servers, each running one microservice, 2 servers running another microservice, and etc. So there's all this large scale level redundancy in my deployment. So that's the concept of microservices. You just need to understand it as a concept as to how it could then take advantage of certain things in AWS, like Fargate or something like that. And we'll get into that in a minute. And then the concept of immutable infrastructure. Immutable infrastructure, well, it's not mutable infrastructure. So immutable means unchanged. So think about this. So you have a mute button on a microphone, right? So you hit the mute button, and now you can't hear it anymore. And then you have unmute. Well, if you didn't have an unmute button, that microphone would be immutable. You couldn't change its state from on to off and from off to on. Okay? Now, they're not directly related. I'm using that as a way to help you remember it, okay? So immutable means cannot be changed. And this is used throughout the programming world as well, and so forth. Now, to understand this, understand a mutable infrastructure is one where when we need to make changes, we just do an upgrade. And then we need to make another change, we do another upgrade. When we need to use the immutable infrastructure, when we need changes, we make all those changes and then we do a replace of the entire, maybe it's a server, maybe it's a container, whatever. We replace the whole thing rather than upgrading what's already there. So what's the difference? Well, imagine I have a server and there are 13 components that need to be upgraded on that server to get from state A to state B that I want to be in. And 12 of the upgrades work, but one doesn't. I now have my server in some weird incomplete state. It's not in state A and it's not in state B. It's in a state that maybe it's even working, but it's only 3 months later that I realize something's breaking because that 13th thing didn't get updated. With an immutable infrastructure, I would never do that. I would never upgrade an in-place thing. I would replace it with a whole different thing. Now, the easiest way to implement immutable infrastructure is through containerization with things like Kubernetes and mass scale deployment of containers, so that anytime I need to make a change, I just change the container and then redeploy. And the container is redeployed as an entire solution. Okay, so that's the concept of immutable infrastructure. Now, some more services we need to know about here. First of all, we have Comprehend and Poly. I love both of these. So first of all, Comprehend is about NLP. And NLP is not neuro-linguistic programming, if you've heard of that outside of the IT space. No, it's natural language processing. So natural language processing is all about saying, if I process this language naturally, I take it to mean X. So it's looking for meaning, sentiment analysis. It's looking for insights and connections within the text. The thing that you and I do, right? Whenever we are actually listening to a conversation, we're understanding everything they're saying based on everything they're saying, not based on each individual word alone necessarily. So that's the concept of natural language processing, and Comprehend is a service that does that for you. Poly is a service that converts text to speech, and it's more lifelike than some of the old text to speech you may have heard in the past. So it's not going to be perfect. It's not going to sound like my voice right now. And I'm not indicating that my voice is perfect. I'm saying it's not going to sound completely human necessarily. If you listen close, you'll hear those artifacts that make you know that it's not. But it's not going to sound like this either. So it's certainly better than some of the old text-to-speech, okay? So it's more lifelike. And you can basically just put text in an S3 bucket and it will generate the speech audio file for you, and you can come back later and get it. Or there are other ways to use it through APIs too, programmatically. Then we have RDS proxy, which creates a connection to RDS databases, and then the databases connect to the the applications connect to the RDS proxy. So it's kind of a go-between between the applications and the proxy and the database service. Why would you use that? Well, every connection into the database service consumes resources, memory resources, compute resources, and so forth. Every connection in consumes those resources. So if the connections are all made directly and you've got tens of thousands of connections, it can really cause a degradation in performance of your database service just because of the overhead of all the connections. Now, what if instead I could have, instead of 1,000 direct connections, I could have 10 connections to the database service and then 100 connections to each of those connections through the RDS proxy. That's the picture I want you to get. That's what this does for us. And it avoids over-consuming of RDS resources. Then we have AWS X-Ray. This is a troubleshooting tool, a debugger for distributed applications. Think microservices, serverless applications, things like that, which can be very hard to troubleshoot and debug. You know, normally when you're debugging a monolithic application, it's all right there. It's all on one server. We can analyze and troubleshoot it. With distributed architectures for an application, we may have 13, 14, 15 different components that are distributed across multiple machines that are all working together to accomplish an end task. One might be doing a mathematical operation while another's doing some natural language processing, while another's doing speech to text. And another one is doing text to speech. And all of these are happening at the same time. And to get from my click of a button by user to the end result page we need, all of them need to do their job and then bring back my results. Clearly, that's harder to debug. It's harder to troubleshoot. X-ray helps in those kinds of scenarios. Another thing to understand from a conceptual perspective is service quotas and throttling. Now, service quotas aren't something you implement. It's something Amazon implements within AWS. So they constrain how much of something you can consume, like how much space a particular object type is allowed to take up, or how many connections you can have into a certain service, and so forth. They're quotas. They are not necessarily quotas you can see in your AWS management console, but they are in the documentation. So for example, if you search the documentation for service endpoints and quotas, you can see what the quotas are for all of those different endpoint types. Just as an example, the maximum size of an S3 bucket policy is 20 kilobytes. Now, realize policies, they can be created through GUI interfaces, or they can be created through direct JSON code, right? Or in some places, other code. So the point is, if I'm doing it directly through code, it can't be bigger than 20 kilobytes. It's just not allowed. So what do you do if you need one that's 21 kilobytes? You're going to have to request a quota extension. And then Amazon may or may not approve it, depending on what it is in the scenario and what you need. And then throttling is implemented, again by AWS, to ensure that service quotas are not breached. And you'll know if you hit a throttling problem, because when you try to do something through an API against the AWS service, you're going to get back a request limit exceeded. That's the message response to your API. So what you would need to do in your application is have some code that looks for a response of request limit exceeded. And if it gets that, maybe it waits for half a second and then tries again, or an entire second and then tries again. And then what I would recommend is something like a second delay, try again. If you get it again, a 5-second delay, try again. And then if you get it again, notify the user that we're unable to request the process at this time. Please try again later. So that does help with that. Well, maybe you sort of met it, but now the throttle's allowing you back in again and you can get in. So again, that's all in your application code. You don't have to know how to write that code, but it's good to know what to recommend to the developers. All right, so that deals with the resiliency section. Let's go through the high performance topics now. So here we're talking about performant topics within AWS in the new exam. First of all, database and data systems to know that might be new. First of all, we have Amazon EMR. Now, this is a good point for me to note something. You may have noticed this, and it's interesting to know there is a difference. So you see, this is Amazon EMR, but we have AWS Lake Formation. What is the difference between something in Amazon's AWS called Amazon X versus AWS X? Do you know? Well, if you don't, basically, if it starts with AWS, it's a standalone service. And if it starts with Amazon, it's more of a utility service. I'm sorry, I said that backwards. If it starts with AWS, it's more of a utility service. If it starts with Amazon, it's a standalone service. So Amazon EMR, think of it like one service that does everything X. And AWS Lake Formation, a utility that does some work for you, maybe servicing other services and so forth, right? So that's an interesting variation, and I don't feel it's perfectly consistent in my mind as to what some of the AWS named things are. To me, some of them are full-scale services, but Amazon considers them apparently utilities. So what is EMR? Well, EMR is a petabyte scale big data solution. So it's allowing you to implement big data in the cloud. You've got everything there, your analytics, your machine learning, all of that is there. And you also have your implementation of this based on open source solutions like Apache, Spark, and things like that, right? So big data in the cloud, that's Amazon EMR. AWS Lake Formation, this allows you to create a data lake. If you haven't heard of a data lake, imagine you've got all of these ponds or other sources of water, it might be underground water, that result in streams that flow all into one place, and that one place is the lake. Okay? Well, that's the concept of a data lake. It's all your data in one place. I don't know why they didn't go ahead and use the analogy of a data ocean. I guess maybe that would be everyone's data all in one place and not just yours. But a data lake is all your data in one place. Now, it might be structured, formatted, whatever, according to some needs that you have, but it's all your data in one place. And AWS Lake Formation is a utility service that allows you to pull data from all these different locations and bring them together to build that data lake. Amazon Athena is an interesting one. This allows you to query data in S3 buckets. So you can have data in S3 buckets, and then you can use standard SQL to query it. The actual data itself might be, it's generally a text file, but it might be CSV data, JSON data. JSON is the JavaScript object notation format for data. And sometimes I say JSON, sometimes I say JSON. People say it all ways. I say it all ways. It doesn't really matter. Just know that it's a text file structured in a certain way. And CSV, you probably know, comma separated value, right? So there are different ways it might be stored. Basically, Athena allows you to run SQL queries against that kind of data. And then QuickSight is another interesting one. This allows you to use natural language queries against data. So instead of having to say select customer, comma, city from customers, you can say, tell me all the customers in city X. That would be natural language, right? Now, when you do natural language, what it really does is in the back end, it converts it to a proper query for the database, and then it executes that query. But that's what QuickSight is about. Glue is about data discovery, preparation, transforming data, right? And combination for data analysis and other tasks. So Glue is about being able to go and get all the data from different locations and glue it together so that it works together as if it's one data source that can be used for analysis and insight. And then data sync allows data to be moved to and from different storage systems or between storage systems and services. So synchronizing your data, right? Now let's talk about some more performance services before we wrap up this section very briefly. First of all, we have AWS Fargate. This is a serverless compute engine, and it uses containers. So you can see here, if I didn't have Fargate, I have to build my container image, deploy an EC2 instance, provision it with the appropriate compute resources, isolate, pay for that instance, and then I can run my container on that instance. With Fargate, I just build my container instance, define the requirements, and say, okay, here's the money for it, use it, do it. That's it. I'm done with AWS Fargate. I have to deal with all the instances myself, okay? AWS Batch is about doing very large-scale batch processes or compute processes, maybe hundreds or thousands of them at the same time. So when you think AWS Batch, don't think I have a single compute process I need to execute. Think I have many compute processes I need to execute. And then finally, the AWS Global Accelerator is about making sure that user traffic can move to and from a service as quickly as possible. In a brief nutshell, you get a couple of IP addresses that are given to you, and the traffic can go through one or the other. And AWS will automatically route the traffic to the best one at any given time for the best performance for that traffic. So that's really what it amounts to. It's a kind of load balancing, but it's global in scale. It can be routed to completely different regions for that matter. And that gives us our performance overview. Now, very briefly, we can do the cost optimization overview. It's not as detailed. So what we're going to talk about here, first of all, is something called requester pays storage. This is the one we're going to go into the most detail on. With requester pays storage, it's a type of S3 bucket. And what this means is that it's an S3 bucket where the requester is charged instead of you. And you just configure the S3 bucket to be requester storage. And then basically what's going to happen is the requester has to have an AWS account. They're going to authenticate to it, and then they're charged for access. That's requester pays. So makes it so you're not charged for someone else accessing the data. There are a couple of ways it could be used. Maybe you're charging other companies to access data. Maybe you have different accounts for different departments, and you want each department to have to pay for their access to the resource in that S3 bucket. So that's another way to think about it. Now, the final thing then is some additional cost optimization concepts. Remember, you do have savings plans. This is where you predetermine the usage that you're going to need for a year, and then you pay for that. It's less expensive than on demand. You get a reduction than what it would be if you paid on demand throughout the year and ended up using those same levels of resources. So if you can very accurately predict the resource you're going to require, then savings plans can be beneficial. You also have the AWS Cost Explorer, and it tells you what you're spending money on, right? Most used services, availability zone usage, most used accounts, these kinds of things. And then finally, you have the AWS Cost and Usage Report. Now, this is something that's stored in S3, and it's going to break down your cost and usage into great detail so that you can analyze that to find out where your expenditures are going and possibly implement some appropriate optimizations. Well, that brings us to where we say thank you. This is where Tom says thanks for attending this event and provides additional guidance. What is that additional guidance? Well, in a very quick 30-second nutshell, I can't give you every detail of all of these components and parts and pieces that we've talked about here today, but I can tell you where to go to get it. In a few weeks, revisit the course and you'll be able to access those resources right there, going into greater detail than we did here today with demonstrations and so forth. In addition to that, in the meantime, you can start doing some reading in the AWS documentation. Just search on these things and begin to explore the documentation. But here's one thing I'd like you to do. Now that you've gone through this with me today, get the PDF of the objectives for SAA CO3, open them up and read through them and see if you can identify the areas in there where all of these things I've talked about are specified. Believe it or not, it's a really great exercise. And right now, what I'd like to do is thank you for joining me on this live stream. I hope you've gotten some value out of it, and I look forward to seeing you on another event in the future. Take care, everyone.